So today we're going to get a little bit more into graphing, but they do have a little bit of a preview of graphing. So I think a few of us at least should know that if I graph something like this, does anybody know what that looks like if I graph it? All right, let's do this. I'm going to take a minute to graph this, and then we're going to answer that question. All right. So if you don't know what something looks like in a graph, what do you do? What can you do to try to graph it? It's not a straight line, so there's no idea of slope or anything. So what can I make to try to graph this? Yeah, I know what you mean. Like an XY?
Yeah. Negative 1, 0, 1.
Sure, you can at least try those. If you have no idea what it looks like, you maybe want to try 5 inputs. It's crazy, I know. So let's try... what's going to be good here, Jeff? Let's try -2, -1, 0, 1, 2. It's kind of like my go-to 5. Stay looking at it. This course is not heavy on graphing, but every now and again there is some graphing involved because math is better understood if you look at it in several different ways. So graphing a function gives us a nice visual of what the hell it's doing. So we know what lines are all about. Now we got to look at the next level up, the second power. What the hell is that going to happen? Well, what do I get when I plug a -2 in there? What's f of -2?
Minus 4.
Good. So you get 4 minus 8. -4, cool. All right, you guys take a second and finish that out for me. I got tired. Let me catch up to you guys. So when you plug a -1 in, what do you guys get come out? -3. When you plug a 0 in, yeah, 0, everything just zeroes out, right? When you plug a 1 in, 5. When you plug a 2, yeah, because you get 2 squared plus 8, 12. So if we graph this, we can kind of get a feel for what's going on. But let me remind you about one other thing. I mean, this is like if you have absolutely no idea about much beyond graphing, beyond just plotting points. But we know something about graphs. We know how to figure out intercepts. What intercept did I already find? 0, 0. So I already know one x-intercept, and that's the y-intercept, right? It's actually both. But there's one more x-intercept. How do I find, in general, how do I find an x-intercept? You actually do the same thing all the time. To find the blank intercept, I set everything else equal to 0, really. So to find the x-intercept, I make y 0. Now where the hell's the y? What the hell? Where's the y at in that equation? Good. So this is what took the place of y. So to find, this is kind of funny. The last math course I took, I don't know if I brought this up before. It was like Math 896. Then I did some independent study, but that was the last math course I took, Math 896. Rah. To find the z-intercept, what did I do? I set all the other 30 variables equal to 0. So to find an intercept, you make the other variable 0. So to find the x-intercept, I make y 0. How do I solve this? remembers how to solve that? You don't have to. You could, but you don't have to. Not on this problem. You only have to use quadratic if you can't do what? You could, but quadratic is just a shortcut to completing the square. The only reason you would ever complete the square quadratic is if you can't factor what's there already, right? Can you guys factor x squared plus 4x? Second? Yeah, what comes out of both of these?
X.
X. So then x is 0. That's the one we already knew. Or x is -4. Shit. So now I've got another one from that. -4, 0. That's an x-intercept. When y is 0, x is either one of these. I already had that one. I didn't have that one. And the intercepts are good anchor points to find. Okay. Maybe. All right. So if I plot this, what do we get? We get 0, 0. I got to go up to 12. So let me go 2, 4, 6, 8, 10, 12. Okay. So let's see, I got 0, 0. That's cool. I've got -2, -4. 4, 6, 8. So it's -2, -4, -6, -8. Is everybody cool with that? Your scale can be different on your x and y, but it's got to be the same all across that axis. So it's by 2 here, it better be by 2 there. It's by 1 here, it better be by 1 there. All right, it's buy 1, get 1 free over there. Sorry, that's all I could think in my head. So -2, comma, -4, -1, -3, 0, 0, 1, 5, 2, 12. Cool. And then I got my -4, 0. Now I'd be interested to see what -3 does, just to kind of complete that picture. If I throw a -3 in, I get 9 minus 12, I get -3. So it's right there. You can do it, Jeff. Yay. So what would you say the lowest point is? You see how this thing now goes? It goes like that. Yeah. What shape is that? That's right, parabola. Parabola is the correct way to say it. Well, I say parabola. What's the lowest point there? Yeah, -2, -4. Does anybody remember what that point is called? That's just about the most important point on there, is that lowest or highest point if it opened down. Vertex. Kick ass. All right. So parabola, an x squared, if the highest power in the function is x squared, it's going to look like a parabola. It's going to be opening up or it's going to be opening down.
This is kind of like a question about, in terms of practicality. But is this used for something like architecture or something like that? This kind of formula, stuff with parabola and vertex?
A lot of architecture we see, we use formulas. And of course, the formulas are kind of set up according to what physics will allow things. So I want to set up a building, and if I want to make it look interesting, I probably want to check and make sure that by making it look interesting, I'm not going to make it fall out, for example. I'm not going to make too many stresses and strains in the wrong direction. So a lot of the formulas, we say, I want it to be shaped like this, and then you set up a formula that incorporates the physics, and then the people come back and say, I can't do that, or else you want everybody to die. We're like, no, we don't want that. So change the formula around a little bit. Okay, cool. Now the physics says nobody will die. We'll do that. And like the St. Louis Arch, for example, it's not a parabola. It's actually a different function. It's a little bit beyond us, but they actually model it based off a mathematical function. Right? That takes away a little bit of the glory of that for you. I'm sorry. It should actually add to it. Kind of like us saying, hey, we know freaking math. Look at this shit. Right? That's awesome. We're proclaiming that.
This is kind of like the gateway into the whole...
So what this is used for, the most immediate use for this, is to find, what we're going to talk about today is a quick way to find this. If I can find this point quickly, very often that's the only point I need. Not always, don't get too excited. You will have to plot some of these, so you need a lot more points than that. But for example, if I tell my boss, yeah, this is the model for profits. This is the profit for a company. If we make too few things, then we're going to lose money because we're not going to sell enough, and we got to pay rent, we got to pay electricity, we got to pay whatever. You with me? So if we don't make enough stuff, we don't sell enough stuff, we're not going to make enough money. If we make too much shit, then we're using too much cost as far as material to make this stuff. So somewhere there's a sweet spot in the middle. So we're always trying to figure out, how do I get here? You guys semi with me here? Now obviously, the equations aren't always as simple as this. And the equations very often will end up, their functions will end up looking like that. But obviously you want to try to be there. Right? If it can't be there, then you try to be at one of these other peaks. You're always trying to get one of the peaks. Which peak can I get to? What would it take for us to get here, Johnson? We need about $5 billion more. Okay, screw that peak, Johnson. I want to get the right peak right there. All right, we can do that one, boss. Cool. Right? That whole conversation just existed in my own head. It's neat. You guys, then obviously this function is disgusting, but the idea of finding the highest or lowest peak or valley is a general idea. So we're going to get into looking at parabolas and figuring out what's the lowest or the highest. If I plot my cost function, then obviously I want to find the lowest point of my cost function. Does that kind of make sense? So depending on what the function represents, you want to find the low or the high point. And how do you find that? You find the vertex. You find what's called a turning point. How are we doing so far? You guys doing all right? Maybe that was too open of a question. Can you guys do like this? Is everybody able to do that? One of you guys are like, I can't, I don't want to. All right, fine. So, finally back to the actual question, right? Leanne's sitting over there going, does he remember? There's another question. How many x-intercepts did this have? Where were this guy's x-intercepts? How many x-intercepts did it have? How many times did it hit the x-axis? Twice, right? We found them mathematically, and you can see them now that we graphed them visually. There are two places where it hits the x-axis. There's two x-intercepts. How we doing? Does it always have to have two x-intercepts? I've graphed a couple of examples over there, or at least one, where it doesn't have any x-intercepts, right? Do you guys see that? This has no x-intercepts because it starts there and it goes up from there. Ain't no way it's going to come back and hit the x-axis, right? It's just going to keep on going up from there. So you could have no real intercepts. You could have one if it hits once, or you can have two. Now obviously, hopefully it's obvious, you can't have more than two. In order to have more than two, I have to have a function that can actually turn one more time at least. You guys with me? Now here's an interesting point. That's a little bit beyond what we need, but it's interesting anyway. What's the degree of this function? Which is also known as the highest power. 2. How many times did it turn? When I graphed it, how many times did it turn? Once, right? Always will be at most one less turning point than the power. If this would have been a third power, it's going to have at most 2 turning points. If this was an 8th power, it's going to have at most 7 turning points. It's really kind of nifty. It's kind of neat. If you let it be. All right. All right. Some of you guys look less than impressed. And I don't care, because it's still cool no matter what you think. So, finally, when they ask us how many real solutions are there, if I said how many real solutions are there to this equation, there are 2, because there are 2 places where the function is 0. So if I said how many real answers are there to this equation, none. I love it. Big ass. So for the problem they give you, it looks like this. Number 10? Right? Number 10, they give you this guy. Oops. And they ask you how many, and then they graph it for you. Shwoop. Roughly like that. And they say, how many solutions would this have here? How do they put it? There it is. How many solutions does that equation have? Do you see how you can subtract 6x over? So this equation is the same as this parabola being 0. Right? That's the parabola they gave me. So it does have 2 solutions, period. That's all there is. Yeah, cool. Now here's the interesting thing. See if you guys remember. If it looked like this, it still has an equation like, who knows? Maybe it's got an equation like that or something. You with me? It doesn't have any real answers, but it's got to have 2 answers, so what kind of answers would it have? I kind of gave you a hint. What kind, not how many. I know it's got to have 2 answers. There are no real answers, because it doesn't hit the x-axis anywhere. What kind of answers will it have? Imaginary, the only other kind there is, right? There's real, or there's not real, complex. How we doing? All right, cool. You guys, okay. Any other questions from homework? Anything else from homework? From anybody? No? Okay. Cool. I'm an optimistic fool, so I'll take that to mean it's going really, really well. Right? And not that you're not doing it. That would be silly. So last time we actually got into section 13.2, and I kind of proved the quadratic formula, right? So what I want to do is do a couple problems several different ways. If I gave you a section of problems that just said solve, and the first problem I gave you was there's a long way to do this and there's a short way to do this. So what would you do to solve this?
Do you subtract 3 first?
Yeah, good. Subtract 3. Kick ass. Because where's my variable at? Where is it at?
On the left.
Inside what?
Parentheses.
Yeah, inside the square. So if I can get this thing by itself, just like we do with absolute values, just like we do with radicals, right? We see the same idea. If the equation would have been this, we would have subtracted 3 first, right? Get the absolute value by itself. If the equation would have been this, then we would have done the same damn thing. We would have subtracted 3 first to get the radical by itself. Holy shit, there seems to be a common theme. You get the thing by itself where your poor variable is stuck. So then you can break into that, whatever the hell it is, and free your variable up. Right? So if I do subtract 3, what can I do to free my variable?
Square root.
Yeah, the opposite of the square is square root. Kick ass. And the minute you take a square root, what has to happen? Who remembers? It's got to become second nature.
Plus or minus on the other side?
Plus or minus, kick ass. So you can catch both answers, right? X squared equals 4 has 2 answers, 2 and negative 2. Because you square either one of them becomes 4. So this side, bam. This side, plus or minus 2.
But
Now, yeah.
you add 1 to the other side, right? Right now?
I could,
Yeah, that's-
but what I would highly suggest is, since this is not a radical, this is actually like terms with the 1. What I can do is,
Yeah, just write it down twice.
solve both of those.
Yeah, okay.
Yeah, that's fine. Because now it's like terms with the 2. I can actually, when I add the 1 over, I can put it together with the 2. If that was square root of 2, I couldn't add 1 to it, so that's why I wouldn't break it up. But here I should be able to get nice answers. Right? So what do you get from here?
Oh, 3.
You add 1,
Yeah,
2x is 3, so x is
3 over 2.
3 over 2. And there you add 1,
You get a negative 1.
Negative 1. X is negative 1 over 2. Pretty cool. So if your x's are already all gathered together, that kicks ass. Somebody's already done work. If you go and square this and FOIL it out, you're undoing a lot of work somebody else did. That would so desperately suck. Because then you gotta bring the 7 over, and then you gotta try to factor it, or you gotta try to quadratic formula it. That's gonna be long. I don't want to do that. It's basically already kind of put together for me. It's awesome. If you do FOIL this and you do that, you're not going to get it wrong. You're just going to take more time than you should. All right, so what if it doesn't look like that? What if I give you this one here? What would you try first? What do you think?
Well, no.
See if it factors, right? That's what I try first. And this bad boy does not do that, right? There's no factors of 5 that make 3. Right? 5 is only 5 and 1. I can't make 3 out of that. Okay. Now, if you subtract 5, it sounds like you're going in the direction of completing the square. Maybe. And that's not a bad idea, except that might be a little bit worse than what we need to do. Because can you imagine completing the square? What's the steps to complete the square you'd have to take? How do you complete the square? What steps do you need to do? Yeah, take this middle guy, divide it by 2, and then square it, right? So let's maybe do that so we can all remember how to do it.
Okay.
I don't hear any other suggestions, so we're going to do that.
I'll ask
Subtract
at the end.
5. What's that?
I'll,
Cool, we'll do that second, since your suggestion came in late. So just to remind you guys, because it kind of looked to me like you forgot.
are you going to factor out the x, or you're not?
No, can't. No, definitely don't. The whole point of completing a square is to try to make it look like this. So then I can square root. Right? This is the whole point. So I don't want to take the x out. I want to add something here so that this will factor like that. So what steps do I take to figure out what number has to go here to make that work? First step is?
Divided by 2.
Good. Take the middle term divided by 2. All right. Second step is? Good. Square. You guys have handouts that you actually, I didn't say you couldn't use them. This is not a quiz. You can actually just have them sitting there in front of you if you want to. You can have the book open to the section. It's crazy. All right. This is not a test or a quiz yet. So if you don't know the answer, try to find the answer. So yeah, I'm going to take this guy and you square it.
Yeah, square. And then you put it on top.
So this is going to be
9
fourths. Cool. I like it. What's up? Is that all right? Yeah, good. So then this is what I have to add here. And if I add it there, I better add it to the other side. That's what I have to add to make this work. And this tells me what? It's kind of nice. If you remember. Do you want to factor this?
No.
No, but this tells me how it factors. It'll be x minus 3x. Always. The first step will tell you how this guy would factor. The second step tells you what you have to add to make it work. It's really neat. It's a little backwards. The second step is what I have to do first. And the first step tells me what that would become. Right? But oh well, I think I can handle that. It kind of factors for me. Kick ass. I like that. Equals. Now what the hell happens over here? Sweet. LCD. Cool. Always. Right? They're fractions, so you need an LCD.
Oh, you're asking us what's the answer?
Yes, always.
Oh, okay.
That's why
4.
anytime I'm standing here looking at you guys,
Okay,
it's because I'm expecting
Multiply it
something.
by 4?
Yeah, so 4.
Okay. I was like, wait.
Alright, so I get x minus 3 halves squared equals coolness. Now this is where you're no longer allowed to say you can't go forward, because yes you can. Right? Why would somebody think they can't go forward? Because somebody would be like, I've done enough shit on this problem, man. Is this problem going to end? No.
It's square.
What's the next step?
Square.
Square root.
Square.
I want to kill that square, right? Same thing we did there. I want to kill that square so that my x can get the hell out of there. So if I take a square root, why would somebody think that's bad? Square root negative, but we're cool with that. We can handle that. That just means what's going to show up? An I. Kick ass, right? So if I take square root, what do I need to put?
Plus or minus.
Plus or minus. Cool. And then here I get
Where? Oh. I don't know. You.
I can't do that yet. Not yet. I mean, what is the square root of that square? Now, at this point, can I add 3 halves? No, the square's in the way. I'm stuck inside of it. After I take a square root, now I can add 3 halves, right?
Oh.
That square rooting frees it up from being under the square. I can't. Before that, I can't do it. So on this side, what do I get? What's the square root of 4? That's crazy. What's the square root of negative 11? Good. I square root of 11, because I don't know what the hell square root of 11 is. The square root of negative 1 is I.
Oh, and you take the negative.
And now we do, like I said, Naisha's over there saying, come on, man. Just add the damn thing. So now the last step, get the x by itself.
You add it.
Add the 3 halves over.
And it stays like that, right? You can't.
Totally.
Oh.
Okay.
You don't graph that, right? Like in the homework?
Graph it. How do you mean?
No, I got confused. Cause we started the class with graphing.
Oh, I see.
Oh, okay. No.
No.
All right. I was like,
In fact, what does this tell me? Let me see if you guys can put together what we did earlier with what we got. These would be the x-intercepts of this graph. What kind are they? Are they real?
no.
No. So this parabola, what would be true about it? There's no real x-intercepts. So if I graphed it, what could that parabola not do?
Oh, like that.
Touch the x-axis. Thank you. Vitalist voice. Yes?
Sorry, how did you get how do you get 9 over 4? Plus 9 over 4 plus that?
This step, right? Take half the middle dude. So now this is the completing the square step. Half the middle dude.
So
Square. This is what tells me to add here so that this will work factor like that.
Thank you.
Anytime. That's what I'm here for. Just to remind you guys, by the way, I mean, why the hell am I here? Why am I here? You guys understand? Yes, I'm here to help you understand this stuff. I think sometimes you don't understand that. I don't know. You want to use me as much as you can. You have me, you've paid my salary, so you want to use that, right? So when I'm asking you to try problems out, especially now, shit, am I ever going to see the work you did on this problem? If you did any work on this problem, I'm never going to see it unless you show it to me. So that is your free reign to do whatever the hell you think you can try to do. And if you're wrong, you're not going to freak out yet because it's not a quiz yet. It's not graded. And if you're wrong, you ask me, I did this, why was that wrong? Right? Desperately need, again, some of you guys are in trouble grade-wise. And I don't know what your long-term goals are. And I don't know if you think I'm going to make you pass just because I'm a nice guy. If you don't pass, you don't pass. Right? So you desperately have to kind of bring something, right? Got to bring something. I'm sorry. Some of you guys might just be that kind of person. You just don't want to speak. But I can't believe that everybody's like that. So here, let me shut up for a while. You guys do this problem. You do it any way you want to, except using technology. You happen to have a graphing calculator, you know how to use it. If you don't know how to do it by hand, you should not know how to do it in a calculator. Yeah, gummit. I'll do this both ways. I'll do a complete square and I'll do quadratic formula. So whichever way you're doing it, I'll do it that way.
That's the completing the square. This is the, so the two steps are the middle term, cut it in half, and the square. Whatever you get here, you add. Whatever you get here is our factors. So when I cut it in half, I got everything as I squared it at 9/4. So I added 9/4 to both sides. And what that did was I made that trinomial that get its factors like that square. That's why it's called completing the square. We add to it what it needs to become a square. And what's great about that is I can then square root.
Plus minus
11.
I.
It's an I.
Yeah, because it had a square root in negative.
Right?
So right here, this is square root of -1 square root 11 over square root of 4. So that's I root 11 over 2. Square root of -1 is I.
Oh, okay.
Yeah, section 12.8, the complex numbers. Yeah, let's see. Yep, good. Good. Oh, what happened there? Oh, it's 25/4, and you just lost the over 4. You see what I mean?
Oh,
Yeah.
okay. Wait, so
It's 25/4, right? Not just 25.
but the answer would just have the fourth over. Like it's right, but
So we 25 over 4, yeah.
so like that.
Yeah.
That's it.
So let's see.
Okay.
Oh, wait. It's
Okay.
even worse than that. Sorry. 25/4 goes here, but 5/2 is what goes there.
Oh,
Yeah,
okay, I
that's
get
my
it.
bad.
No one. Okay. But the other part's right? The 29 and the...
Yeah, the process is right. You just
Okay.
had the wrong number in the one place.
Got it. So...
All right. So step 1 for completing a square. So I can add the 2 to get it out of the way. So I have some room. So what are the 2 steps for completing the square?
Add the
Whatever's in the middle, cut that bad boy in half, right? And the second step, square.
Oh,
Then that's gonna go.
So 25/4 is what I do what with?
It's gonna be your C.
Good. It's going to be my C. AX squared plus BX plus C. I like it. And And if I add it there, I better add it there. Cool. I like it. And what sucks is, as a student, when you forget why a process works, and you start to just go, it's what he keeps doing, so it's gotta be divide the thing by 2. Why? Because that's what the hell he just keeps saying. Shit. He said to do it. Square it. Square it? Sure, why not? Why not freaking multiply by 80 million? No. So, I want you to remember, just real quick, remember, let me put a better number there. X plus 7, we did that. X minus 8 squared, right? We did several of these. You remember that? Not really? Okay. So if you do square this out, you have to FOIL it, right? X plus 7, X plus 7. So it'll be X squared plus 7X plus 7X is plus 14X plus 49. If I do this one, X squared minus 8X minus 8X minus 16X plus 8 times 8, 64. This number is that number squared. This number is that number multiplied by 2, right? So if I didn't know what that number was, I would take that number and cut it in half. Holy shit. So that's why the first step is, whatever's in the middle, I cut it in half. What am I doing? Trying to figure out what this number would be. That's why that number goes right there. So if I cut 16 in half, I get negative 8. That's what must have been there. Now, if I didn't have that number, how would I get it? I would take that and square it. So that's why the second step is square it. It's crazy. You have to kind of remind yourself, why does this process make sense? It does make sense. The minute you start to go, it doesn't make any damn sense, I just cut it in half, and you're going to start to forget it, you're going to start to lose it, you're going to start to lose faith in math, you're going to start all this stuff, right? So many guys are like, dude, I've lost faith in math. I understand, trying to rebuild it. Every damn thing that any math teachers ever wanted you to do, there was a reason for it. It works for some freaking reason. If you don't know why, you just have to ask. This is why I am here. I am more than the book. I am interactive. Right? The book, you can't go, book, tell me why. No, you can say, Jeff, what the hell? And Jeff will say, cool, I love that shit. Ask me questions like that, I love it. All right. So how do I finish the problem? What do I do on that side? Crazy LCD. Good. And what's the LCD? 4. That's crazy. So I have to multiply this by 4, probably, because it's got a 1 right now on the bottom, right? I don't like that. So I get 8. Yeah, so something went freaky there.
Yeah.
8 plus 25. 33 over 4. Cool. Yes, sir.
I got a quick question. How come that became, so we got 25 before there, but how come then we put it into the parentheses and it became 5 over 2?
That's the whole point. If I have, if I have something where half of this squared is this, half of this squared is this, then it must factor like this. That's the pattern that we see. That's how we developed this process. This process exists for a reason. It's because we went, that always happens. Shit. Well, let's use that fact. It always happens, so let's use that. If I can make 3 numbers so that half of this is that square, half of the squared is this, then it has to factor to be half of that there. Period. That's how it has to work. That's what completing a square is built on. So you need to have faith and understand that it works because of the work we put into it. We came up with the pattern. That's why it works. Now the next level would be, all right, it works, Jeff. Why the hell do we do it? Well, what can I do now that I've done that? I can square root it. Yeah, I consolidated all this shit, bam, into one little squared piece, right? So then I can immediately square root it so I kill that square. There's a purpose. So, it's kind of loud. You guys are in the eardrum's going to hurt later section. So if I square root that side,
You do plus or minus.
beautiful, kick-ass. Thank you. I didn't have to be all dramatic. So then this cancels. X plus 5 halves equals Plus or minus rad 33 over
2.
Beautiful. Rad 4 is 2. You do the part you can, or you leave the part you can't.
Oh, don't you need an I in it?
Why do I not?
Because it's on negative inside.
So you gotta focus on why something happened, not just the fact that it happened. Why was there an I here?
Because the negative.
Because there's a negative in there. What's the square root of negative 1? I. The square root of negative 1 is defined to be I. There's nothing special about that. There's no work for that. We just said, what's square root of negative 1? I don't know. Let's call it I.
So
That's it. That's the whole story.
So I means negative.
I means what?
Negative 1.
No, I does not mean negative 1.
No.
I means what?
Oh.
Square root of negative 1. I don't need I to mean negative 1. I'm cool with negative 1. Negative 1 means I owe somebody $1 or something. I understand that. Square root of negative 1 is I owe somebody imaginary money. Right? Play Monopoly or something. Even that's physical. I can hold it. That's not imaginary. That's, hey, I can't buy a cheeseburger with it, but I can hold it. This shit, I can't even hold this. I can't even see it on a graph. This is weird shit. So we decided to call it I just to make it easier to kind of work with. Right? And to be really clear, this is much easier. If I wrote this down, it's kind of hard to see it's complex. But if I put an I in there, that's easy to pick up. I'm like, oh, that's complex. I can see the I.
How come it's not just 1/2?
Where? What? How do you mean?
What happened with the square root of, negative 1?
Yes.
Oh.
Square root of negative 1 is I.
Yeah, it's not 1.
That's the key. Now here, do I have a negative?
No.
No, so there's no I in there, right? Is that cool? All right. So last step here. Subtract 5 halves. So you get negative 5 halves, give or take. Rad 33 over 2. Now I promised you guys I would do this both ways. So that's completing the square. Did anybody use quadratic formula? Anybody? 2 of you guys. All right. So this is for you and everybody else. You guys what? What's up?
I just kind of plus or minus.
So are you cool at this step here?
Yes.
All right. So you're cool with the plus or minus?
Yes.
Because the minute you put a square root, you got to put plus or minus. So that plus or minus is still there. And all I did was I broke up the square root. What am I taking the square root of? 33 and 4. So if it's under the square root and you can do it, you do it. The square root of 4 is 2. Square root of 33 is... square root of 33, shit. Right? So if I had the square root of 25 over 16, what's that?
Also 5 over 4.
Beautiful. Now watch. If I had the square root of 29 over 16, what's that?
29 over 4.
Careful.
No. The square root.
Why is that 5? Because the square root of 25 is 5.
Yeah.
So what comes on top? The square root of 29. What's the square root of 29?
The square root.
I don't freaking know, so we'll call it square root of 29. And what's the square root of 16?
4.
4. Do you see how those are the same exact idea? Why did I write that one better? Because I could. Square root of 25 is 5. Square root of 29 is, I don't freaking know. 5 point something. I don't know. So with the square roots, how do you work them? You do the part you can, you leave the part you can't. So I did the part I could, and I left the part I couldn't. Maybe. Okay, let's see. Oh yeah, so let's do this one with quadratic formula. So remind me, what's the quadratic formula? Quadratic.
That's
You
the,
can ask.
that's the longer way.
And that was a
right?
nice melody too, I like that. It's got a good beat.
That's the
Yes.
long way to do it? Is that the long way to do it?
This is actually a shortcut for
Oh, a
some.
shortcut.
Personally, if there's a 1 in front of the x squared, I do completing the square. In fact, it kind of depends. If there isn't a 1, I might go ahead and do quadratic formula. Well, watch, because with this, I have to divide by the number if it's there, and I might make all these gross fractions that are easy to make mistakes with. I don't care how good you are with math. I'm really good at math. I am. It's the one thing I'm good at. But even I will make mistakes with negatives and with and fractions. Why? Because I am a human. right? And that's the definition of being human, is you will make a mistake somewhere. So if I want to use this, what's A, what's B, what's C for this problem? What's A?
X.
Careful. A is the coefficient. These are all, A is 1.
Oh.
The coefficient of x squared. B is 5. C is -2. Kick ass. And then you just plug and shove. Now some people overuse this. You use this for everything in the world, even if it's an easy factorable thing. You just use it. I desperately want you to try not to do that. All right? You've got to be able to factor stuff. But on this kind of problem, you can't factor the damn thing, so you can use this. So negative B, so negative 5, give or take, 5 squared minus 4 times A times C. So now I'm just plugging values in. Over twice A, which was 1. Is that cool? Just plug it in. And why is it so relatively easy? Why is it just a plug and shove? Because we did all the work ahead of time. Remember that horrible... I made you guys sit through that derivation of the quadratic? If you guys weren't here that day, it's too bad for you. You missed out. It was awesome. Ask around. They'll say, we don't know what he's talking about. Well, yeah, we did all the work ahead of time to get here. So this should be easy. So what can you do? How can I simplify this?
Holy shit, it's faster.
It's crazy.
Yeah, so 25 minus...
-5 plus or minus
25.
25.
Wait, plus 8.
Yeah, minus is plus 8 over 2. -5 plus or minus square root of
33.
33. Is that the same thing we got?
Yeah.
Yeah. Dudular. Most of the time that will be a shortcut. That's why it was created. Sometimes this will actually be quicker, believe it or not.